Aloha, or as they say in Hawaii, hiya! Here to do some higher tier maths this afternoon. I'm going to do some graphical inequalities, talk about how we can represent inequalities on a graph, and then use them to identify regions of a graph using multiple different inequalities. So let's get straight on with that, and yeah, go. So heading straight over to where I can draw, and it's quite difficult now because we've got one screen. I have to trust that I'm drawing and you can see it. So here's hoping. What I need to do is as follows. I need to get a graph. So we're going to start off with a graph. Now, in order to represent an inequality, for example, if I wanted to represent y is greater than 5, I would then need to draw first of all draw the line of y equals 5. And we can draw that just by putting a line through there, marking it as a 5 on there. So that would be the line y equals 5. If we want all the places that are greater than 5, my first job is to change this line if it's possible to do so. I don't know if it is. So it's a dotted line. So let's see if that is a doable thing. I don't even know if it is. I've certainly not worked out how to do that. No. But it would normally be a dotted line. So what we're going to do to fix it the other way is we're going to change this so it says y is greater than or equal to 5. Now, all the places above the line will be where y is greater than 5. Let me prove that by choosing a point. On this point here, y is 10. So if y is 10, 10 is greater than 5. So all the points, this point here, y is 12. All the points here, the y value is greater than 10. Remember, in inner coordinate, you have an x value and a y value. So what we do is we then just shade all the places greater than or equal to the line. And remember, if it is or equal to, it's a solid line, and we'll do another one. In blue, we're going to do x is greater than 3. This time I'm going to put 3 here, and I'm going to do a dotted line because it's just or equal to. And it goes straight down like this. And that line is x equals 3. So all the places where x is bigger than 3. So remember, thinking about the coordinates, something like 4, 5. We can go to 4, 5, and it would be here. So this side of the line must be back greater than. Now you'll notice by doing 2 on the same one, what you start to notice is that sometimes they overlap. And if I use and I can keep shading this, if I use the highlighter, this section here is both greater than 5 and greater than 3. So it allows you to identify specific regions. Now this is very useful for things like business, and there's a whole area of A-level maths called decision maths, which you do a lot of this linear inequalities where you identify regions where your optimal solutions lie. And inequalities are very good for finding optimal solutions to a problem. Now, we've just done this one here. We're going to do just a different one now. But how can we use that? Well, what if x is less than or equal to 3? Y is greater than 0, and y is also greater than x. What would that do? Well, we've got 3 different inequalities, and the first thing we've done is we've talked about how to draw inequalities on the graph. So let's sketch them each out. So we're going to snap to a shape, so hopefully this will be nice straight lines. First one, x is greater than 3, so I'm going to do or equal to, so we've got a nice straight line there, and you can see how good I'm getting at straight lines. I think because it's solid, I think I'm just going to draw that like that. Then we've got y is greater than 0. We've already got the y equals greater than 0 line just here. The axis is the y equals 0 line. Okay, and we've also got y is greater than x. To do that, we draw the line y is equal to x, but because it's not, we're going to use a dotted line for the line y. Oh, that's a terrible line, Mr. Harris. That's what I meant to do. That line is the line y equals x. Notice how I draw the line for y equals x, then I shade in the bit that's above the line. So let's look at where we're going to shade. Well, the first thing we did was y is less than or equal to 3. So that's all of these bits here. Then we said y is greater than 0, so we want all of these bits here. Then we want y is greater than x. Now the easiest way to do this is to choose a point. So for example, on this point here, y is 4 and x is minus 1. Is it true that y is greater than x? Yes, 4 is bigger than my... I've got the coordinate the wrong way around. Higher tier maths. Minus 514. The y value is bigger than the x value, so it is true. So therefore we want everything that is that side of the line. And you'll notice there is a specific region here I can shade in that meets all criterias, and that would be there, there, and there, and then we can colour in all the rest of the graph that is in that region. So this region represents all the possible values. And then you can just always choose a value from that region that meets the criteria. So I can just say, well, now choose a value that meets the criteria. Okay, I will choose this value here. This value is 1, 3. So the value x is 1, y is 3, meets all 3 criteria. And we can check it. Is 3 less than or equal to 3? Sorry, is 1 less than or equal to 3? Yes. Is 3 greater than 0? Yes. Is 3 bigger than 1? Yes. So it meets all 3 criteria. So you can always check a point to see if you've got it right and see if you're defining the correct region. I'm just going to quickly flip so with me so I can see if there's anyone has joined live. I've got a few people watching live but no chat at the moment. So if you do have any questions, please feel free to use the live chat because I will happily just check and respond to that. And I'll come back here. So hopefully that makes sense. We can also do more complicated ones. So the next one we're going to talk about what if it's like a pair of equations to look at. So these are all linear inequalities. So what about if the line says y is greater than 3x plus 1 and x plus y is less than 4. So what I need to do first of all is work out what equations these need to be drawn. Y equals 3x plus 1 and x plus y equals 4 are the two lines we're going to draw. Then we work out which side of the graph we want. So first of all, y equals 3x plus 1. I'm going to put 1, 2, 3 and 0, and I'm going to go x, y nice and quickly, 0, 1, 2. So 3 times 0 plus 1 is 1. 3 times 1 plus 1 is 4. 3 times 2 plus 1 is 7. That tells me 7 is quite useful to go up to, so let's go up in 2s. 2, 4, 6, 8, 10. So we're going to go 0 went to 1, 4, 7, 0, 1, 4, 7, straight line that pierces all of those, something like that. And then what I haven't done, I'm going to make this easier because I wanted to use straight lines. I'm going to make those all equal to. Just, it doesn't matter, it would just be a dotted line if I was drawing this with pencil and ruler. My other line is x plus y equals 4. Again, I already know that x plus y equals is going to be a straight down line like that. But I use this with the zero method. So the zero method is this. When x is 0, when y is 0. When x is 0, x plus y equals 4. So y must be 4. When y is 0, x must be 4. So if I put those 2 points in, I can then link them. And roughly speaking, it's going to be a long one down 4, so it's going to be approximately there. That could have been more accurate. I had it and then I involuntary spasm. There we go. So we now need to decide which side to shade. So we want the y value to be greater than 3x plus 4 plus 1. Remember, this was y equals 3x plus 1. Now, in general, when the y is greater, we go above the line. However, it's always useful just to check a coordinate. So let's have a look at this coordinate here, 1, 8. At the coordinate 1, 8, is it true that 8 is bigger than 3 times 1 plus 1? 3 times 1 is 3, plus 1 is 4. Yes, that's true. Therefore, we want that side of the line. And that's a good way of doing it. Choose a random point and say, is it true or is it false? If it's true, we want that side. Next, x plus y is less than 4. So we're going to choose a random point, 2, 4. At 2, 4, is 2 plus 4 less than 4? 2 plus 4 is 6. No, it's not. So therefore we don't want that side, which means we do want this side. So we do want the side which is here. And then once I've got the sorry, I could turn all these into arrows to show where I want. I can now use a highlighter to show that I want there, in this little tiny gap, and there, and then everything in between. And sometimes your question will say, label it with a region R or something like that. So that's the region R indicated by those two things. Now we can even finish off the region if it then said 1, 2, 3. If it also said that y is also, sorry, not y, x is also greater than -3, we could also rub out some of that highlighter, draw the line y equals -3, so it's -1, -2, -3. It's a dotted line here because it's greater than, it's not greater than or equal to. Then we want x to be bigger, so if it's bigger we go to the right or above. So we're going to shade in all the bits to the right of this. Notice I ignore the other lines for the moment, just go to the right there. Now when we come to do the highlighting, we can only go up to this line, but it completes a single region. This region now is not infinite, and only the points inside this green region meet the criteria. Now it's worth noticing, when you shade in a region, the points along this line here do not, oh, I've rubbed that out, didn't mean to do that. The points along the line do not feature in the solution. So these would be solutions. That point's a solution. That point's a solution. And even that point's a solution because it's on the line. And so is this one. But these points are not solutions because they're not featured in, they're in the dotted line. We'd have to go in one to find a point, a whole number point or an integer point, which is in the rate shaded region. Okay. So that's a brief introduction. I'll have a quick look and see if there are any questions, but that's a brief introduction to how you can draw inequalities, draw them on a graph, and use checking the points to see how they interact with each other in order to shade the regions. I hope that's been useful to you. Feel free, if you're watching this live or if you're watching this later, put a comment a question in the comment below. I'll happily get back to you on it. I will shortly add a worksheet that goes with it. That'll be just straight after the video finishes. I hope that's been useful. That's the last higher tier lesson I'm going to do for a while now. I'm going to have a summer holiday where I'm going to get some other bits done. But in September, I will be coming back and weekly doing higher tier revision things. I have classes that will want to be using those. So both for my school and for anyone else who wants them, I'll be doing some higher tier revision classes right the way from the start of the course, and they will be supporting the lessons that my students are doing. So you can follow on along, try and keep up. If you're year 9 or year 8 and want to try and get ahead of the game, that's fine. If you're year 11 and wanting to catch up, if you're redoing any GCSEs, all of those things are going to be mean that coming on, subscribe to the channel, watch the videos, ask me for questions. If there's some specific topics you'd like me to do in September, please let me know. I've really enjoyed working with you all through lockdown. I'm going to have a bit of a break for a few weeks. However, Do pay attention in September when I look to try and relaunch and do a few new good things. I'm going to try and make some worksheets for you all, so they're all nice and well presented. And yeah, thank you for joining me. I've been Mr. Harris. You haven't. Look after yourselves and take care.